Alrighty, boys, I need redemption, okay? You gotta know that I made two silly mistakes on AOIME, and no, I'm not gonna redo number 9. No, I'm not doing a casework bash. Wait, it's not even a casework bash, it's just literally list out all the possibilities. I'm not doing that. But we are gonna start off with number 11 and try to work our way up. Hello everybody, I'm Karar, and today we are gonna do some more AOIME walkthroughs, specifically the AOIME, and we will see how it goes. Alright, let us start with problem 11. Let p of x equals x squared minus 3x minus 7, and let q of x equal and r of x be two quadratic polynomials with coefficient of x squared equal to 1. So they are monic, so that's cool. David computes each of the three sums, p plus q, p plus r, and q plus r, and is surprised to see that each pair of these sums has a common root, and each of these common roots are distinct. Okay, if q0 is equal to 2, and then r0 is equal to m over n, find m plus n. Okay, so I think the idea is you just had to make a bunch of equations. So let us say that p of x is equal to what is given, and then q of x we'll say is like, well, why don't we do x squared plus a1 x plus b1. Yeah, okay, that's right. And then r of x is equal to x squared plus a2x plus b2. Epic. Well, let us say that the three common roots are p, q, and r. That's not confusing at all, but it'll be fine, right? Hopefully. So basically we can say that p and q are the roots of adding these two, q and r are the roots of adding these two, and p and r are the roots of adding this with this. So we could find the sums. Let's do that. So px plus qx is what? It should be equal to 2x squared plus, plus a1 minus 3x plus b2 minus 7, or b1 minus 7, okay. And then we got the same thing for the other stuff, so I'll just write them out. Okay, so these are the three sums that we got to think about, and we know what their roots are, so now we just have to use Vietas, I think, because basically if you got roots and you got coefficients, the best way to use them is to do Vietas. Okay, so we basically know that the sum of the roots is negative b over a, so we could say that 3 minus a1 over 2 is equal to p plus q. 3 minus a2 over 2 is equal to p plus r. And then we could do for the last one, it would be negative a1 minus a2 over 2 is equal to q plus r. Very cool stuff. And then we could do the products as well. So we know the products are just c over a, so b1 minus 7 over 2 is equal to pq, and then so on and so forth. Okay, so these are the 6 equations we have, and that's basically just using the first two sentences, right? Or yeah, first two sentences. And then the third sentence we could actually use in a different way, right? Basically, we know that q of 0 is 2, so that means that q of x is equal to x squared plus a1x plus b1, and if we plug in x equals 0, then the only thing that's left is the b1. Okay, epic, so now we know that b1 is equal to 2. b1 equals 2, very good stuff. So now we can plug it in here, and we get that pq is negative 5 over 2, and this one becomes a simpler equation. This becomes like 1 plus b1 over 2. What the heck happened there? 1 plus b1 over 2. Okay, and now I'm assuming that we could literally just divide these. No, actually that doesn't really help. Hold up. If we subtract these, do we get anything nice? Well, essentially we should be able to solve for one of these things. Well, okay, let's say we subtract these two, right? Then we basically get that 3 plus a1 over 2 is equal to p minus q. And then if we add these, then we basically get, if we add this one with this one, then we get 2p is equal to, oh, this is nice. 2p is equal to 3, so p is equal to 3 over 2. Does that make sense? Okay, yeah, let's say p equals 3 over 2. But then there's symmetry, right? No, never mind. P is the okay, p is the odd one out. Okay, well anyways, you know p is 3 over 2, b is equal to 2, b1 is equal to 2, so now you could do even more stuff. Let's plug in. So that basically means that, oh, that means we already know what q and r are in terms of a1 and a2. So we know that q is equal to negative a1 over 2, and r is equal to negative a2 over 2. And do we know anything more about this? Oh, well, I mean, this just tells us, okay, so that's done with this equation. Epic. So, in fact, we could solve for q now, because we know that p is equal to 3 halves. So this right here is 3 halves, so we know that q is negative 5 over 3. OMG, we're getting so many variables, it's not even funny. Which means that a1 is equal to 10 over 3. Oh my god, we did it, boys! Okay, well, not quite. Wait, actually, did we? Okay, no, we need b2. b2 is what we're trying to solve for. But we basically know everything, right? So we have pr. Well, we don't need this anymore, we're done with this equation. And we're done with this equation. Okay. So now we have a2, b2, and r that are unknown. So wait, hold up. So this is 3 halves r. And then there's negative 5 halves r, or 5 thirds r. Hold up, we have two equations and two unknowns. What does that mean? We could solve for r, and then we could solve for b2, and then we're done. Okay, so subtract these two, or is that the best way? Okay, let's say we subtract them. Then this would be negative 7 over 2, so it would be negative 9 over 2. And then the right side would be 3 halves plus 5 thirds, which is 9 plus 10 over 6, which is 15 over 6, which is 5 over 2. Wait, what? That's not right. What the heck? Do I not know how to add? Oh, wait, 9 plus 10. Oh, no, 19 over 6. Okay, that makes a lot more sense. Okay, and then we multiply and we get 27 over 19, negative 27 over 19 is equal to r. And then if we solve, wait, let's try to plug it into the last one because that seems easier. Then we basically get negative 5 thirds times this, which should be 45 over 19. And then we subtract 1, so 45 minus 19 is going to be 26 over 19, and then times 2. So b2 is equal to 52 over 19. Wait, am I right? So we're subtracting 19, so it should be 26, okay, and then multiply by 2, and we are good, I think. So the answer should be, theoretically, 71. Let us check the answer. Let's go, we got it right, 52 over 1971, let's go. Basically, whenever you have a polynomial problem, what the heck? Basically, what I was trying to say is whenever you have a polynomial problem, you gotta basically do Vietta's formula if it has to do with coefficients and if it has to do with roots. Whenever I see roots, I just try Vietta's. You might as well try it, it's worth it. Vietta's is pretty OP, not gonna lie. But I don't know why there's a Vietta's problem at number 11, because usually that's the first thing people try, but whatever, it's okay. And that wasn't even hard math, that was literally just a bunch of linear equations. Don't ask me. Okay. Okay, let us attempt number 12, but on the actual competition, I looked at it and I got scared because it's like pseudo-geo or something. So why don't we try it? Okay. So m and n are odd integers greater than 1. M and n made up of unit squares. Okay. And you got a bunch of stuff. Okay. So basically, you're trying to find the number of ordered pairs such that in this mn rectangle, the centers of these two squares intersects the interior. Dang, this is complicated. Okay, so basically we got a rectangle. Wait, is it true that, like, if mn works and nm works? No, I don't think, no, that doesn't work. Okay, so we have to, okay, well, why don't we just try to find a pattern first? So, oh, but these m and n have to be massive, though, to have 2,000 squares, so I can't just test it out. Wait, this is so confusing. How the heck would you even start it? Well, okay, why don't we try converting it to, like, well, yeah, mn coordinates, right? So this would be positive m axis, and this would be positive n axis. And that means that, like, your n coordinate is going to be your number, mod n, right? Or mod n. And then your m coordinate is just going to be your number over n. Integer divide over n. Okay. So now we have our coordinates, and does that help us find whether it intersects the interior, though? Well, basically we have 200 over n. Oh, wait. Okay, so we literally don't even have to worry about m then, because the only thing that matters to us is n, because that could determine the coordinates exactly. So that's fine. So our first coordinate is going to be, this is our m coordinate, and then our n coordinate is going to be 200 mod n. And then, let's say that's here or something. And then our other one's going to be 2000 mod over n, and 200 mod n. Okay. And then we wanted to pass through something. This line should pass through the other thing. That's actually kind of complicated, though. Well, we know that, like, 1099 is, like, approximately halfway between the two. So, it's like m coordinate is going to be approximately halfway. So the idea is that its n coordinate should also be approximately halfway. Wait, why don't we just try 2001, right? Does 2001 work? Because then this is 200 mod that, and then, so this would be 200 as its other coordinate. This would be 2000 as its other coordinate, and then this one would be right in the middle. What would its oh wait, yeah, that works because all of them are on the same row, so that just makes sense. So n equals 2001 works, and then now we need to figure out. I'm assuming that only one thing will work once they're on opposite rows. Let's see. Well, so this is for when we only have one row. What about when we have two rows? Then basically we need it to be approximately, well, is that even possible if you have it on two separate rows? Yeah, it is possible, right? So if it's on 2 rows, you'd want your 200 to be here, your 2000 to be somewhere there, and then your 1099 would be, wait, that's like not possible though. Oh wait, it's odd though, it has to be odd, so then we go to 3 rows, and this guy should ideally be here. Because we know that 1099 is approximately in the middle, so we want it to be like that. If we put it here, then it would be like in between here and here, so it would end up being somewhere over there, so that's not going to work. Okay, so the idea is we want to have these on opposite corners. Wait. Hold up. Well, basically, if 200 is on the first row, we know that n has to be greater than 200, right? And we know that like the 200 is fixed, right? As we increase the width of the first row, the 200 is going to stay in the same place. The only thing that's going to move is where your 2000 is. So that's good, I guess. And where your 1099 is. Wait, yeah, so I think it's better to think about it in terms of how many rows you have. So if we found it for 1 row, but now we have to find it for 3 rows. How the heck do we do that? So it should be 2000 approximately at the end. So what's 2001 over 3, let's say? 667. So let's say it's 667 then, right? Then this guy's at 200. This guy is at 666. Then 1099 minus 667 is what? 2, 3, 4. 432. So its y coordinate is 2. So we gotta check whether the unit square. Wait, hold up. What? No. Oh wait, n equals 2001 doesn't work because m has to be greater than 1, so that doesn't work. Okay, so I guess we're at square 1 again. Oh, wait a minute. Wait a minute. So what is the center square? The center square has to have a number. I mean, let's see. Or rather, what is the center square from 2000 to 1? So let's say 2000 is here, right? Is there guaranteed to be a center thing that this line passes through? Like, what's the square right there? Okay, let's think about it this way. So you got your 200 somewhere here, and you got your 2000 is somewhere there. Wait, shouldn't it just be exactly half of this, like right in between? So in this case, shouldn't it just go directly through like whatever this is, 1100? Wait, so if it goes through 1100, then the only way that it goes through 1099, which is right there, will be if the slope is like here, if it goes like this. If it's, okay, so basically, we know that it has to go through 1100, right? Because that's like right in between the two, right? But then the only way for it to go into this square, which is 1099, is for this to be less than 1. So that shouldn't be too hard to count. So essentially, we know that 2000 has to be on the last line. And if there's 3 rows here, then we know that 667 was the smallest one. And then what's the biggest one? It would be 990. Yeah, 999. Okay, so we know that some odd integers between here and here will work as long as the slope of the line is less than 1, or like it's, yeah, less steep than the slope of 1, okay. And then how do we, okay, which ones? So the bigger you make your n, the less, yeah, the less steep, or no, the more steep it is, because your 2000 is moving to the left, right? So as your n gets bigger, this moves to the left. So basically we need to figure out where it stops working, where it's more than, okay. So I guess I'm just trying a bunch of things and seeing when it starts getting too steep. Okay, so the slope is literally going to be 2000 mod n minus 200 over 2, right? It goes down to? Yeah, the slope, yeah, it goes down 2 or 3? 2. Yeah, it goes down 2. So we want this to be greater than 1, or less than 1. So essentially we want 2000 mod n minus 200 to be less than 2. Wait, what? That doesn't sound right. So 2000 mod n is how far to the right it is, and then subtract, oh wait, sorry, this is the inverse of the slope. So the actual slope would be change in y, which is 2, over change in x, which is 2000 mod n minus 200. Okay, that's what it is. And this has to be less than 1. So then essentially we know that 2000 mod n is greater than 202. So we know that 667 gave a mod of like 666, right? And where do we get to 202? So what's 200 minus 202? That would be 1798, and then divide that by 2. Yeah, divide that by 2, and you basically get 899. So 899 will not work because then the slope is 1, so it doesn't pass through the interior of the square. So anything from 667 to 897 will work. Okay, so that's good. Now what about if we had 5 rows, right? Then it would be the same idea. We could apply the same idea. It goes down 4, and then we also have 2000 mod n minus 200. And then it should be less than 1. Okay, so we basically have 2000 mod n is, what is it? Greater than 204. Yeah. And we also know that 2000 has to be on the last row, right? So if we have 5 rows, that means that your n has to be what? Well, basically you know that 2000 over n has to be 4, equal 4. Or at least 4. Between 4 and 5. Okay. So that means you could either have 500 or 501, I guess, all the way over till 400. Yeah, 400. Because if it's any less than that, it'll go on to the next row, so that's not good. Okay, and we know that 2000 mod 501 is going to be what? That would be 500, right? And then as we go down, and then when does it become 204? That would be when it's 2000. Okay, so 2000 minus 204 is what? 1796. And then divide this by around 3, because we want to get to somewhere in here. That would be 5, and then, hold up. When does it become, oh, so maybe it's not, okay, maybe, oh, maybe I had to divide by 4. Okay, so 796 over 4. Okay, that makes a lot more sense. Okay, so 4, and then there's a 1, 9, and then there's a 4, so that's 3 and 6, and then 449. So basically 449 is not going to work, so we got to do 451 to 501. Okay, and then we can do the same thing for 7. I'm not going to bore you with the details. Okay, so I basically found these 4 things, and you can't get any lower because otherwise it would be less than 200, and 200 wouldn't be on the first row. So this should be Gucci. So let us try it. So why don't we add this up? So 225 to 49 is a 24 difference, and then that means that you have 13 odd numbers. Then you got 32 difference, that is 17 odd numbers. Then 50 difference, so that's 26 odd numbers. And then you got a difference of 230? What the heck? That's a lot. Okay, 230. Oh, wait. Wait, okay, that's right. So this is 230. No, wait. Okay, hold up. Wait, actually it's 230. So 131 then? Okay. That seems wrong. Oh, well, okay, so we got 30 plus 26 is 56 plus 187. Okay. Is that gonna be the answer? Oh, God, no, we're off by a lot. What the heck? Hold up. Oh, we got the 13 right, so that's good. Wait, actually, why don't we just see what we did wrong? Oh, what? Oh, so what? It starts working again once you go down? Because then it gets steeper, even? Oh, I guess as you increase n past a certain point... Okay, so I guess, yeah, as you increase n past a certain point, it also becomes more flat. Okay. Well, yeah, that makes sense. What the heck? As you increase n... Wait, no, what? Hold up. Okay, I guess that makes sense. So, instead of doing this stuff, we would take our original bounds, right? And then we subtract 2, I guess. Yeah. Oh, well, that one was hard. I honestly would not have been able to completely solve it on the actual thing. No way that could have happened, even if I spent the whole time on it. But, yeah, basically the idea is you're supposed to find that the middle thing is there, and then your slope has to be less than, between -1 and 1. Okay, makes sense. Alright, thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know if you guys want more of these AOIME walkthroughs. But other than that, thank you guys for watching so much, and see you guys next time.